we continue our discussion of electromagnetic waves by looking at what's called the ray aspect of light. Now, light, we know, travels through space, right? It's how you can see me by looking at the computer monitor, if you're not just listening to this lecture through audio means. It's how camera flashes work, laser pointers. Light uses what's called the ray method to understand how light propagates through a material. Now, a ray is just a mathematical term. It's some straight line that originates at some object or point. So most of you probably seen, in a darkened room, there's a hole in the curtain or curtains apart slightly, and you can see a beam of sunlight, little motes dancing in the beam of sunlight. That sunlight travels in a straight line through that object, through that opening in the current. Light travels in a straight line. That's why we have shadows, right? Where if you hide behind, you see the sun outside, you hide behind a tree, you're in the tree's shadow. You see the light go on either side of the tree, but not behind the tree where it's in shadow. So we're going to look at this ray concept. So think of light as little laser pointers, if you will. Laser pointer is a wonderful analogy of a light ray. It has a starting point and the beam goes in a straight line. And we're going to look at how those light rays go through and transmit, either go into or bounce off of various objects, and how we can use those properties to create lenses, mirrors, and that sort of thing. So the part of the optics that deals with the ray aspect of light and how those rays behave as they transmit through objects or they get reflected off of objects is called geometric optics. And geometric because you need geometry to be able to do this. And all of you should have geometry under your belt. You need to be able to calculate the sine, cosine of objects, the tangent. You have to be able to measure interior angles and things like that. So you need to understand how geometry works in order to understand this aspect of optics. Now, we're going to pretend that lights travel as a ray, but later on we're going to look at light as it travels as a wave. But that is in later parts of this class. Now, for example, the ray aspect. So if you draw the sun, you can draw the sun, rays coming off the sun in all directions, spreading all out from the sun, so all of these rays originate at the sun. The Earth is so very far away that while we know that these rays spread out as they come from the sun, the Earth is so ridiculously far away that when the light rays finally reach Earth, they're basically parallel. So we have these parallel rays of light striking the Earth. And we have, of course, then the Earth casting a shadow behind it. When the moon moves into that shadow, we have a lunar eclipse. If the moon is in front of the Earth and casts its shadow on the Earth, we have a solar eclipse. But these ray aspects are useful in determining how light moves through space, how light moves through materials like glass or transparent plastics, or how light reflects off of surfaces. And we'll be looking at that, specifically reflection, in the next video.